There's a photograph from 2022. A bright ring of light bent into a perfect circle. And in the center, darkness. That's Sagittarius A star, a supermassive black hole at the center of the Milky Way, 4 million times more massive than the Sun. And the photograph is a lie. Not because it's fake, because it's old. The light in that image is 26,000 years old, from the Ice Age, before cities, before writing, before agriculture, which means everything in that photograph already happened. Past tense, done. What's happening at Sagittarius, a star right now? Unknown, unknowable for another 26,000 years, and you're orbiting it, right now, 230 kilometers per second, 200 billion objects, all turning around the same invisible center, and none of us can see what it's actually doing. For thousands of years, we assumed we understood the Milky Way, a band of light across the sky, stars clustered together, denser toward the middle, sparser toward the edges, and somewhere in that density, a center, just more stars. Nothing special. That assumption felt safe. It was wrong. The problem showed up when we tried to look. Between us and the galactic center sit massive clouds of gas and dust. Point a telescope toward Sagittarius and you see nothing. Complete darkness. So the solution seemed obvious. Better telescopes, bigger mirrors. Except that didn't work. The problem wasn't sensitivity. The center isn't dim. It's obscured. No amount of magnification changes anything. You're still looking at a wall. Then radio telescopes started scanning that region. Radio waves pass through dust. In the 1970s, they found something unexpected. A radio source, bright, compact, unmoving, too bright to be ordinary starlight, too small to be a star cluster, too concentrated to be gas. They named it Sagittarius A star. And at first, that felt like progress. We'd found the center, but finding it created a new problem. The radio signature was too energetic, too stable. The more precisely we measured it, the more obvious it became that this wasn't just the center. This was something massive, something invisible, pulling on everything around it. And if that was true, there should be evidence. Stars close to Sagittarius. A star should move differently, faster, in tighter orbits. So we started watching, and what we saw didn't just confirm the mass, it made the problem permanent. In the 1990s, 2 teams began tracking individual stars near Sagittarius A star, Keck Observatory in Hawaii, the Very Large Telescope in Chile, using infrared cameras to see through the dust, watching the same patch of sky, year after year. At first, it looked manageable. A few dozen stars in predictable paths. Just map their orbits, calculate the mass, confirm it's a black hole. Except the stars weren't moving normally. They were moving fast, far faster than anything orbiting a galactic center should, whipping around something invisible in tight elliptical loops. And one star, a blue-white star the team called S2, was moving faster than the rest. S2 orbits Sagittarius A star every 16 years. That's absurdly fast. Our Sun takes 230 million years to complete one orbit around the galactic center. S2 does it in 16. At its closest approach, S2 gets within 17 light hours of the black hole. For context, Neptune orbits the Sun at about 4 light hours. S2 gets more than 4 times closer to a supermassive black hole than Neptune does to our star. And at that distance, it accelerates to 2.5%, the speed of light. 7,500 kilometers per second. That's fast enough to cross the distance from Earth to the Moon in under a minute. The teams tracked S2 through its full orbit, 2002 to 2018, 16 years, close pass to close pass. They watched it speed up. I watched it slow down, frame by frame. The orbit was perfect. Keplerian. Exactly what you'd expect from something orbiting a massive point source. And here's what made that precision disturbing. The orbit didn't just prove mass, it proved concentration. Whatever S2 was orbiting had to be compressed into a volume smaller than Mercury's orbit around the Sun. No star cluster stays that dense without collapsing. No gas cloud holds together under that pressure. No ordinary object survives in that configuration. The mass was there. The location was precise. The volume was impossibly small. Only one explanation remained. And that explanation created a new problem. Because once you prove something is a black hole, you're also proving something else. You're proving there's an event horizon, a boundary in space where light stops escaping, which means there's a region at the center of our galaxy where information goes in and never comes back out. No signal, no light, no data. A permanent information void at the exact point we're all orbiting around. So they did the math. To make a star move that fast in an orbit that tight, the mass at the center has to be roughly 4 million times the mass of the Sun. 4 million suns, compressed into a space you could fit inside the inner solar system. No star cluster can be that dense without collapsing. No gas cloud can hold together under that gravity. No ordinary object fits. Only one thing does: a supermassive black hole. By 2002, the proof was final. Sagittarius, a star, is a black hole, 4 million solar masses. But proving it existed didn't solve the problem. It made the problem worse. Now we knew what we were orbiting, and we still couldn't see it. Not directly, not as it actually is. And that gap, that lag between what's happening and what we can observe, isn't temporary, it's structural. We'd proven Sagittarius, a star, was a black hole. We'd measured its mass, tracked stars orbiting it, but we'd never seen it. So the next step seemed obvious. Photograph it. Make the invisible visible. In 2019, the Event Horizon Telescope photographed M87 star, a supermassive black hole 55 million light-years away, a bright ring, a shadow. Then, in May 2022, they released the second image. Sagittarius, a star, a glowing ring of gas, bent into a circle by gravity. And in the center, darkness, the event horizon, the boundary where light stops escaping. 52 micro-arc-seconds across, like seeing a donut on the surface of the Moon from Earth. For the first time, we could see the thing we'd been orbiting our entire lives. And here's what made it disturbing. The image didn't show us Sagittarius A star as it is. It showed us how it was, 26,000 years ago. The light that formed that image left the black hole during the Ice Age. No cities, no writing, no agriculture. That light traveled for 26,000 years, through dust, through spiral arms, through empty space, and arrived here in 2022, which means the image we're looking at is ancient, not current, history. Right now, Sagittarius A star is doing something. Gas is falling in. Stars are orbiting. But we have no access to that present. The light showing us what's happening now won't reach Earth for another 26,000 years. And here's the part that makes it worse. There's no workaround, no technological breakthrough that changes the speed of light. You can build bigger telescopes, combine signals from dishes across the planet, and at the end, you're still looking at something that happened 26,000 years ago. The image is always historical. The observation is always delayed. So photographing the black hole didn't close the gap. It demonstrated the gap is structural. We are separated from the center of our own galaxy, not just by distance, but by time. A 26,000-year lag built into space-time. Every observation arrives late. Every measurement is outdated. And that lag compounds. 4 million solar masses. That number sounds abstract. So let's make it concrete in a way that matters. If you placed Sagittarius A star where the Sun is, the event horizon would fit inside Mercury's orbit. 24 million kilometers across. 17 suns laid side by side. Small compared to the solar system. But the gravity is not small. Earth, at its current distance from the Sun, orbits at about 30 kilometers per second. Comfortable, stable, predictable. If you replace the Sun with Sagittarius, a star Earth would need to orbit at 1/5 the speed of light to stay at the same distance, 60,000 kilometers per second, and your year would last 4 hours, not because the orbit shrinks, because the mass warps time, bends space, changes what stable means. Now here's where it gets worse. The event horizon isn't a surface. It's not a shell you could touch or land on. It's a line in space where the concept of escape stops working. Inside that line, all paths lead inward. You can fire your engines at full thrust in any direction you want. Doesn't matter. Every direction becomes toward the center. Not because the black hole pulls harder, because space-time itself is curved so steeply that outward stops being a direction. Light itself cannot escape, not because it's not moving fast enough. Light always moves at light speed, but inside the event horizon, even at that speed, every trajectory curves back inward. The geometry traps everything: matter, light, information. Think about what that means for the center of our galaxy. There's a boundary, 24 million kilometers across, and everything that crosses it is gone. Not destroyed, not obliterated, just gone from the universe we can observe. No signal comes back, no light returns, no information escapes. If a star crossed that boundary right now, we'd see it fall. In 26,000 years from now, we'd watch it approach, watch it redshift, watch it fade, and then it would be gone, and we'd have no way of knowing what happened inside. The event horizon is a one-way membrane in space-time, and it sits at the exact center of everything we're orbiting. And once you cross that line, the delay doesn't matter anymore, because nothing you do inside the event horizon can send information back out. No light, no radio, no signal of any kind. You could be a light year inside the horizon, traveling at half the speed of light away from the singularity, and you'd still be moving toward it. The geometry won't let you leave. That's what 4 million solar masses does. It doesn't just pull, it restructures causality. And here's the part that makes the lag unbridgeable. Even if we built a probe that could survive the trip to Sagittarius A star, even if we sent it all the way to the event horizon and it transmitted data back, that data would take 26,000 years to reach us. The black hole we're trying to study is always 26,000 years out of sync with any observation we make. There's no fix. Light moves at a fixed speed. The delay is locked into the geometry of space. The center of our galaxy is not just distant, it's fundamentally inaccessible in real time. And that inaccessibility compounds every time you try to interact with it. 26,000 years. Every piece of information from Sagittarius A star arrives that late. Light, radiation, gravitational waves. The black hole in that 2022 image is how it looked during the Ice Age, when humans were small hunter-gatherer bands with no cities, no agriculture, no writing. So, what's happening there right now, at this exact moment? Unknown, unknowable for another 26,000 years. And here's where it compounds. S2, the star we've been tracking since the 1990s, orbits every 16 years. We've watched it complete multiple orbits. Except we haven't. We've watched orbits that happened 26,000 years ago. Right now, S2 is somewhere in its current path, approaching or receding, and we have no way to know which. The same applies to every star near the galactic center, every gas cloud, every event. If Sagittarius A star suddenly flares, if a star gets shredded, if the accretion rate spikes, the change happens in silence. We see it 26,000 years later, after it's already finished. We're watching old footage on an endless loop, and the footage updates slower than civilizations rise and fall. By the time we see something happen, it's already more ancient than the pyramids, more ancient than agriculture, more ancient than writing. Every current observation of the galactic center is older than recorded human history. And here's what makes that severance absolute. You can't send a probe to fix it. Even if you built something that could reach the galactic center, even if it survived the 26,000-year journey, the data it sent back would take another 26,000 years to return. Round-trip communication, 52,000 years. You'd send a signal asking, "What's happening there?" and the answer would arrive 52,000 years later, by which point the question is meaningless. Whatever was happening is now ancient history twice over. There's no real-time control, no live feedback, no way to adjust or respond. Any interaction with the center of our galaxy is fundamentally asynchronous. Separated by timescales longer than human civilization has existed. That severance is written into space-time itself. Light has a speed limit. Information follows that limit. No future technology changes it. No probe moves faster than causality allows. The center of our galaxy exists in a present tense we cannot access. And the black hole doesn't adjust for that. It's still there, still pulling, still structuring everything around it, including us. Sagittarius A star doesn't just exist at the center. It defines the center. Everything else positions itself relative to it. And here's what that actually means. You're orbiting it right now, 230 kilometers per second, fast enough to circle Earth in 3 minutes. But the center is so far away that one complete orbit takes 230 million years. The last time our solar system was in this exact position, dinosaurs hadn't appeared yet. The next time we come back to this spot, Earth might not exist. That's not a choice. That's the reality of being gravitationally bound to something 4 million times more massive than the Sun, and it gets tighter the closer you are. S2, the star we've been tracking, completes its orbit in 16 years. S62, another star even closer, orbits in 9.9 years, reaching nearly 10% the speed of light at its closest approach. Farther out, at the edges of the galaxy, 80,000 light-years from the center, stars take hundreds of millions of years per orbit. Every star, every gas cloud, every object in the Milky Way is locked into this structure, orbiting, always orbiting. And the farther you are from Sagittarius A star, the longer the lag. We're 26,000 light-years out. So our lag is 26,000 years. Stars at the edge of the galaxy are 80,000 light-years from the center. Their lag is 80,000 years. The entire galaxy is orbiting something none of it can see in real time. A central mass that controls the structure but remains out of sync with everything around it. Think about what that means for interaction. If something catastrophic happened at Sagittarius A star right now, if the black hole suddenly flared to 1,000,000 times its current brightness, if it started consuming matter at a rate that fundamentally changed the galactic core, we wouldn't know. Not for 26,000 years. By the time the light reached us, the event would be ancient history. Finished. Done. And we'd still be reacting to something that already happened tens of thousands of years ago. There's no warning system, no early alert, no way to prepare. The galaxy orbits a center it cannot monitor in real time. And that creates a structural blindness. Everything responds to a version of Sagittarius A star that no longer exists. You cannot escape that orbit, not without accelerating to speeds far beyond current capability. And even if you could, you'd still be orbiting something. Another galaxy, another black hole, another center of mass. Gravity doesn't stop. The structure doesn't dissolve. You're always bound to something larger, always turning, always delayed. Sagittarius A star is patient, unreactive, uncompromising. It doesn't need to be. It just pulls, slowly, relentlessly, and everything near it follows the same inescapable path, including you. So here's what we've learned. Sagittarius A star is real. 4 million solar masses, 26,000 light-years away. Proven, measured, photographed, and proving it revealed something unfixable. We orbit a black hole we will never see in real time. Every observation arrives 26,000 years later. You cannot interact with it. You cannot respond to it. You cannot synchronize with it. Right now, Sagittarius A star is doing something. Gas is falling in. Stars are orbiting. But the light showing us what's happening won't arrive for 26,000 years. By the time it does, human civilization might be gone. Earth might be unrecognizable. You're not orbiting Sagittarius A star. You're orbiting the memory of it. No telescope will change that. No probe, no breakthrough. The universe doesn't allow it. The black hole at the center of the Milky Way is not something you will reach, not something you will know in the present. It just exists, somewhere ahead of you in time. You've been circling it your entire life, and you'll keep circling it until you're gone. Always turning, never arriving, always late, never current. The center of everything you know exists in a time you cannot access.